Hello, folks, and welcome back to Learn Synthesis with Pure Data Season 2. This is Episode 3. We start off this Series 2 making a granular synthesizer, with Episode 1 being about making a looping synthesizer that had pitch control. And then in the last episode, we started granulating the sound, basically making a mechanism that allows this looping almost like a virtual tape of looping sound, being able to be sent out in what are called grains, almost like packets of samples, packets of sound, little by little. What we're going to do in this episode is make that output of grains smoother. If you remember the end of last time, any kind of speed changes to the sound that we would want to do resulted in a bunch of distortion. Things called artifacts, basically waveforms that were jumping from different values to one another and not moving smoothly and creating that distortion effect. So we will be making windows, specifically a Hanning window, to basically shape the amplitude of these packets of grains so that they don't create that distortion effect, but we get maybe the more desirable pitch shifting and other effects that we are looking for in granular synthesis. So away we go. Okay, so here we are. This is my episode 2 folder, and we're going to go into episode 3. Just as a reminder for folks that have been following along and making this patch with me, our modules patch is what we would call our parent patch. And when it opens up, it loads in 2 different copies at present of the granulator patch right here. So the granulator is actually functioning as what we call an abstraction, a patch that gets loaded in from file to another patch. And so you do need both files for this to work. You don't really need the audio because we're not loading that in. We're recording new audio each time we use it. But when you want to send this somewhere else, the easiest way is just to go to whatever folder you have it in, right click on it and go to compress to zip right here. And Mac says something very similar. I think it's just called compress. And then it'll make a zip file like that. You can rename it if you want. You upload this single file somewhere, and this single file actually has the folder that you're keeping things in and all the files in it inside. So anyway, I'm going to make an episode 3 folder and just take what we have so far and put it in there. And what I like to do is, and this is actually something you have to do, when you're loading PD files into other PD files as abstractions, you want to make sure there's no spaces in their file names. They will be case sensitive. When you make an object to bring like granulator in, it's case sensitive. So I always just use lowercase and I use underscores to separate any words that I want to use. And then if this thing deals with audio, right at the end I put a tilde on it. So that way anybody that's opening these knows that that's an abstraction that carries audio. And I first open things up in PD-Lorc. And you know what? I just might go with this anyway. Even though this episode, this series is Learn Synthesis with PD. PD-Lorc is another flavor of PD. Those of you that are taking a class with me that involves PD-Lorc, you are welcome to use it if you want, because everything we make here will work in Lorc. Those of you who are using PD Vanilla in this series, just watching it and following along, you're more than welcome to stay with that. That's just fine. One thing that I found to be an advantage is that when we right click and go to open and actually look at some patching, PD Lork kind of looks a little bit more, it looks a little better because it puts these little curves and things on patch cables. And I know with some of my classes that I teach, sometimes it's hard for people to see which outlet things are coming out of. Here I just put PD Lork in the PD Vanilla GUI mode, and I think it'll be easier that even if you're working with PD Vanilla, it'll be easier for you to see where my patch cables are going to and from. So let me know in the comments if you mind that at all. I think it'll be an advantage, and we'll see. Okay, so I'm going to close things. I'm back to the modules view. This is the abstraction PD granulator. We have, well, it's just called granulator _ mono, right? That's what it's called on disk. Granulator _ mono tilde.pd. So last time I showed how to make objects and just do that. What I've decided to do this time is we certainly don't need two of them. That was just to show you how abstractions work. I just hit Control E to go into edit mode. I could just simply select that, delete it. All we need to work with this granulator and make it better and better and better is the ADC and the DAC that we have in modules. See, I took two cables from the outlet here to go left or right side, so that way you hear the same sound on the left and the right, and you don't have things just coming out one ear, which sounds annoying. And then I am going to also shrink this down. PD Lork, which I'm working with, just like PD Vanilla, all have the feature that when you edit things like that, you can hit Control S, and the next time I open it, the window will be this size. So a lot of times when you want to share your patches with people, you know, any sub patches that you have open and things like that, PD saves the way it looks at the time you save it. And a lot of times it's nice to just close things up like that. So the next time I open modules, I'll also close this PD window here. Next time I open modules, it maintains its size, and so it looks nice. Let me arrange my screen a little bit here. I'm going to put our PD console window over here. If I ever need to look at to see if there's an error or something, I am going to close my file folder there. Don't need to see that. And there we go. Now, you can go to your file folder and edit the file granulator _ mono tilde.pd directly, or you can right click on it, go to open, and here we see our abstraction. And we're mostly going to work from this. The reason why we still have this is where our ADC is and our DAC, so that when we want to test things out, we just close this window, the gray box goes away, and we can now use this, and we have sound flowing through it. So anyway, just to show you where we're at, press this to record, and I'm recording sound now. Uncheck it, and then we can go here to press this to record, and I'm recording to play it back. And ever since week 1, we've been able to change speed and pitch control right here. The thing is, as you'll see, with what we did last week, it sounds grainy. Press this to record, and I'm recording sound now. Press this to record. Okay, and the reason why it's doing that is I'm going to right click on it and open it again, is because our playback mechanism over here, I mean, it's not like the first week where we're playing from start to finish and looping and just playing this waveform back and just changing the speed at which it comes back. We're chopping it up now, and that's in the playback subpatch here. Remember last week we added this stuff here. This is what's granulating it. Basically, this was the main playback mechanism, but now it's working through samp hold with the granulator, such that this will be playing back, sample numbers. It'll be providing us sample numbers 0 through however many thousands of samples long it is. And when you don't change the speed of it, it's playing at the sampling rate, and you get your sound unpitched. But now that we're chopping it up, it sounds grainy. And this chopping up process has two parameters to it. It's grain speed right up here. I'm hitting Control E to edit it. And if I lift this up, it'll be easier to see. And that comes in and controls the phaser here that's playing from 0 through the length of the grain. And that's where that arrives right here. It's called grain size. So it's going like from 0 to maybe 100. And then once it reaches 100, the way the samp hold works is it basically goes ka-chunk. And basically it pops through a sample number from here that would be 101. And then this system goes from 101 up to 200, ka-chunk. And then 201 comes through, and it goes from 201 up to 300, and so forth. So it's playing it in spurts. And so when you change the speed, these spurts kind of like get chopped up and broken up, and it's almost like they have sharp edges and stuff, so you get the graininess. So that's what we're going to fix this week. So our three magic parameters that allow us to achieve effects so far are the playback speed up here, which is controlled by this speed slider here. You see, I just slowed it down. We have a reset function where you can reset it to 0, and it's now normal speed again. Press this to record, and I'm recording. There we go. And over here, we haven't really set up a mechanism to control grain speed, and we haven't really set up a mechanism to control grain size. We will be doing that in next week. But right now, what we want to accomplish is use this handing window so that these grains sound a little bit smoother coming out, so that our pitch shift that we already have doesn't sound as grainy as it sounds. Okay, so what I'm going to do first of all is widen this window, because we're going to need a little more real estate. And I like to keep the patches looking as clear as possible. And what I'm going to do is I'm going to select by hitting Control E. We're in edit mode. I'm going to try to select here. From here on over, once you select like that, grab anything that's highlighted that's part of the selection, and you can move the whole selection. I'm going to move it as far as we can and still have it look nice, just to give us extra space here. We're going to need it. Now this 0 here is something we need, but let's see if we can kind of move these messages so that there you can see where the patch cables are coming from and where they're going to. Can't completely, what would you call it, uncross them, but basically these things are, if you go back through these episodes, basically each of these sections has their own triggers for playing, that's the left one, and stopping, that's the right one. And basically there's a 1 and a 0 here for turning on and off sound, so that when it plays you hear sound. When it stops playing, it turns it off, because otherwise you might hear phaser just kind of sit in one spot making a little bit of sound, and it's just not necessary. Okay, so anyway, just explain now what we're going to do. we have this grain size that is the size of the grain, and this phaser that's playing from 0 up to the grain size, and that goes through, it gets added to whatever sample comes out of this that's playing the whole table. And so basically this is what allows us to play it chunk by chunk by chunk. And what we're going to do here is put a window over this, which is basically an amplitude envelope. Now, I'm just looking at some of this junk here, and I'm thinking there's some ways to make this look a little cleaner that would be nice. For example, we have a 0 message here, and we have a 0 message here that are really doing the same thing. Each time we play back, we want the different phasers to start at 0. So I'm going to delete them. And I am going to make one message up here for doing that. Now you see I have a 0 here that is for zeroing out phaser when we stop playing. You see it's hooked up to the stop side. Well, guess what? We have another one of those over here. We could clear those out of the way, and we can have both of these functions, setting phaser's phase and zeroing out when it's done playing. We can have that handled by one message. Right here's the trigger, bang, bang to stop things. Actually, it's 3 bangs. One turns off sound, and the next one's supposed to just stop the phaser. That's all we need. So I'm going to make a trigger, bang, bang. We only need 2 bangs to do this. Here, we're making our thing a little bit more efficient because then it's easier to see in the patching what things do. What I'm going to use here are sends. Remember good old sends. Just type the letter S space. We always like to put $0 in because it's an abstraction. And this send symbol would then be unique for each time this abstraction is loaded into a parent patch, which I explained last time. Let's call this this is what? This is phaser 0. Basically a message to tell phaser to go to 0. Now we actually got to put the message here. I'm doing this as a kind of a cleanup because as we add some things here, I don't want things to get too snaky with patch cables and too confusing. This actually might even make, for some folks, things a little bit more clear that we've already covered. So this is sending out a 0 message under the name phaser 0 when stop is selected. When that toggle goes to 0 and stop is selected, this is being triggered. Now we just need to put in receives that receive this. Receive $0 underscore phaser 0. Basically making the phaser frequency 0. And we put it through the left inlet of the float box right there. So here we have the phaser the playback speed for phaser being received and coming in. And we also have this coming in. We don't need this number box anymore. That was to explain some things in the past, but basically our playback speed that our slider effects happens when that gets sent. We want it to go to the left side because we want, when it changes, for that change to go through. And in a float box, if you put things in the right, it just holds the number there, waiting for a bang to send it. We still want this bang to start it. maybe we can make that even a message. Since we're clearing things up here. This might have been stuff I should have done right from the beginning. But, well, it just happens. So we're going to receive $0, start playing. Basically, it bangs the number that's being stored here, whether it's off. This playback speed will basically come through. Oh, that's right. This off can't go there. No. Because then it gets stored. We want it to go into here, which goes into phaser. So basically, when things get turned off, this will turn off phaser. And this stores our playback speed. Whenever it's sent, it'll go straight through because it's going through the left inlet. But whenever it's just sitting there, that number's still there. The last playback speed that was sent is still there, so that when we want to start, we can start it like that. Okay. And we're going to actually clear out these guys as well and make this all much smoother. So what do we need when we're starting and stopping? Well, we're going to make another message here. Remember, the things I just deleted was to turn on and off the sound, really. At the bottom, it's the amplifier. We'll be looking at that in a moment. But basically, when we stop, we want a 0 sent to that. And we're going to send that under the symbol name playback stop. All one word, just to, not make it confusing. Alrighty. So this is for stopping. When playback is supposed to stop, this is, oh, actually, no, I should call this sound off. Or how about this? Sound underscore on off. Because that's really how I'm going to be using this. All right. So we have our sound off, sending it a 0. We're going to have our, what's this called? Phaser 0. This just zeroes it out. There we go. So our phaser can get zeroed out. And we want our we want our sound off. We're calling that $0 underscore sound underscore on off. So let's go back down here. This is where that comes in. Basically zeroing out or multiplying by 1 on this multiplier. So the sound wave gets turned on or off. So we're going to put here control 1. We'll make an object. $0. Sound underscore on off. And we actually need to put an R at the beginning of this. Sorry about that. Meaning it's a receive. So right here is where we receive our sound on off signals. When we stop, a 0 is being sent from the message you see right up there. Okay. This gets sent. Now on this side, we need to send the equal and opposite message of a 1 saying that sounds on. We're going to let a lot of these bangs be here for now, and we'll see how many we need. And once we're done, we can get rid of any that we don't need. So I need to make a message, Control 2, Command 2 in Mac. And that's 1. And that goes to, you guessed it, send $0 underscore sound underscore on off. Make sure there's no typos. Typos keep things from working. So here we go. So when we're pressing play now, We're sending a 1 to that, rather than having patch cables flying all over the place. And I'm doing this because I'm freeing up this space for other stuff. Okay. Let's see. Next, what we want to have happen is to put the phaser at 0. And as you see, that's right over here. And when I say 0, I mean it's phase at 0. I didn't make that yet. So that's something we got to do. We have playback speed here. We have start playback, start playing as a message, as a receive, and we have stop. Maybe we should make these phasers 0. Maybe I should call these just start playing and stop playing. That makes more sense because these are just like the two opposites. This starts playing by banging the playback speed through, which gets things going. This stops playing by zeroing it out, but we have to zero it out down here so that that 0 doesn't get stored for the future. Okay, and now we have to change this over here because here it had the old name. Stop playing. Stop underscore playing. Okay. Now, so before we start playing, a good thing to do is to do our phasing. That's one thing that I don't want to forget. We used to have that in here, a 0 going in. Basically, we make another object, receive $0 underscore phase 0. That means a 0 message gets sent. Because when phaser is going from 0 to 1, 0 to 1, doing its thing, its phase is going to be somewhere in the middle when you stop, probably. And we want to make sure it's zeroed out before you start playing again. Otherwise, playback will start picking up in the middle of what you're doing. Now, you may want that. So that's a feature that could be changed if you want that or not. But we could try it both ways and just see. So we're going to make a message 0, send $0, phase 0. All right, so that's a message that's being sent here. Now, these things also need to be sent over to the side, so let's address them. Because this is a player that needs to run in tandem as well. We have our sound on, off, that affects both, so that's all fine. We have our phase 0. That should go to this phaser 2. So let me just take that receive here. I'm going to select it, hit Control D, Command D and Mac, duplicate it. Make sure you grab the one that's still highlighted and move it on over. So we're going to take it over here to the phaser over here so that this phaser starts. When playback starts, it starts at a 0 phase. Good. Now, wish I would have done a lot of this to begin with, and I'm sure you do too. But you know what? This is good review. Reviewing all the things that are happening. All right, what's next? Well, we need our start playing message. And that's just a bang, so we don't need to make a message box for it. A bang's coming into it, and away it goes. $0 underscore start underscore playing. No, I don't have an underscore in there. You got to keep these things the same. Sometimes I don't remember whether I use underscores or not. Oh, I didn't put the S at the beginning to make this a send object. There we go. So this send object is going to here, which is not too far away, but it also is going to be going to here. Now, what do we need to have happen when this starts playing? Well, this can be moved over to the side, and we'll just put this, let me move it further up, so there we go. So you can see the patch cable is connected to the left inlet of float there. Now, I've already seen one other thing we do need to add here. Receive $0 start playing. All we have to do is bang this float that's containing the grain speed, which is basically going to be in sync with our playback speed to start. The same as what's over here, kind of. But it's calculated differently because the size of the grains are smaller. But they basically are somewhat synchronized to start, but eventually we will make grain speed its own controllable parameter. Next, we have our grain size there. Let me just move it out like this. Now that we're using PD Lork, you can see the curve in the patch cable. You can see what things are connected to. Remember the phase 0? We put that in, right? Phase 0 is put in, but what about stop? Stop playing. Start playing doesn't have an underscore, stop playing does. We should probably change that. Which way do we want to go? Do we want our start playings to all have underscores? Let's get rid of underscores as much as we can. We still have that underscore in the sound on off, but that's all right. Okay, now let's make sure our stop playing over here doesn't have an underscore. They need to match. Deleted the wrong thing. Okay, so now we need one of these. Over here, we have a start playing, we have a stop playing. There it has playback speed. Over here it has grain speed as it should be. And now I'm just going to pop you up here. Now remember where this goes in? This goes into the number box below float, not into float. So let me move you a little to the side so it can be more clearly seen where that thing's going. I guess let me move this over a little bit. Now what I'm going to do is test and make sure it still works. The only stuff we've changed has to do with playback. We didn't change any recording. Let me hit Control S here at this screen, close it, and then we can go here. Let's record a new thing and see if it works. Let's record a new thing and see if it works. Let's record a new thing and see if it works. Let's record a new thing and see if it works. Let's record a new thing and see if it works. So we didn't accomplish anything new, but we know that everything we did works. And I think what this will be is better for people. I think that review probably helped folks out a bit more in understanding what it is we're doing. And at the same time, it's left some space open for us to do something. We are going to be putting some stuff in. Now, as I've been saying, this is shooting things out in grains, in slices. And when you change speeds, either here with playback speed, or eventually when we add grain speed, or add grain size ability to change those, it's going to sound too grainy, and that's what we want to change here. So everything else is kind of hooked up the way it needs to be. So what we're going to do is take something that's going to work with our grain size, and it's going to work with our output down here before our muting. I'm going to try to keep everything on screen. If things do go down further, there is a scrolling function in PD. it does have scroll bars, so we don't have to just stay on this screen, but I want to anyway. So I'm going to give us as much space up here as possible, because what we're doing is going to be up here. This is straight before output. This is where sound gets turned on or off, depending on whether we started or stopped playing. Here's the tab reader that's reading the waveform in the chunks that are happening here. And so what we need to do is put something in the middle here that's going to put some amplitude control over what's coming out of here. And that's what we're going to do next. We're going to make that thing first, and it's called a window. Specifically, we're going to make a Hanning window. And we're going to make another sub patch to put it in there, because we need the space and we can't jumble up that playback view any more than we have. Here, I'm just kind of moving these things a little bit just so things are spaced out. And I'm going to make an object here. Remember, you type PD, then a space, and you are making a sub patch, not an abstraction. Remember, this is not being loaded from the file like an abstraction where the $0 becomes a unique thing for it, and you could have multiples of them and all that sort of thing. This is still considered part of this patch, and all the $zeros are still going to be the same variables, and it's basically part of the same mechanism. We're just going to call it window, and here we go. We are going to make a Hanning window to control this puppy. Now let me see. Just need to make it a little bit big enough. I'm going to hit Control E to edit. First thing we're going to do is make an array. Put array. And the first thing we got to do is name it. PD Vanilla does the same thing. So if you're using PD Vanilla, you just got to put a name in. We're going to resize it later. And its name is going to be $0 underscore, let's call it Hanning, but without the capital. It is a last name, but I like to do no caps when making arrays or symbol names or anything that gets addressed. And we'll just plop it right in the middle here. This is where we're going to make our Hanning window. Okay, I'm going to pause the video just 1 second. I'll be right back. Of course, you won't notice it because it'll be instantaneous. Okay, I'm back. Now, to explain this best, I'm going to close this window temporarily. And, oh, sorry, I have another folder open. If we're going to understand this best, I'm going to first show you one thing here. We're going to go to loading. When this thing starts up, this is, turning on sound, the DSP1 object that or message that we're accustomed to seeing. So I'm going to move things around now that I'm opening things in Lorc. I have a little more space and can make it look a little better. There we go. Not changing anything, just housekeeping. We get our sampling rate right here. It tells us this object gets banged from the load bang, saying what's our sampling rate, and then that gets sent out as sampling rate so that in other parts of the patch we can use it for calculations, and in this stuff you need it. And then there's a 0 message being sent out under the name speed underscore receive. That's this guy. It means to start, we want this slider to be in the 0 position. Otherwise, it'll default to -1, the lowest or the minimum number that it can put out. So that's just to set it up right. These are all things that we need to start. And then we have a 100 message being sent to something called grain size. Grain size is basically as we granulate the waveform, like as we send it out in slices, the size is the amount of samples in the slices as we go. Now let's look at our calculations here to see what's going on there. I think I'll do some housekeeping here as well. So you see here, we have our sample length. This is sent, it's in the recording subpatch. Now I know this is reviewing a lot of stuff that you may already know, but I think it'll help bring things together. Like in the recording subpatch, once this gets recorded to file, loaded into the table, it sends out how long it is in samples. So the sample length is received here. This plus, this is really a number box. It's not an object, it's an adder. PD displays plus whenever the number of digits in something are too many for it to display. Maybe if we just go into its properties. I mean, the number's there. There's no problem with it. It's just what we see is just a plus sign. So I'm going to hit 12 and hit OK. Apply OK. There you go. That's the number that was just too wide to appear. So that's coming in, and that's getting divided by our sampling rate. Because whatever the length of the thing is, and you divide by the sampling rate, you're going to get its length in seconds. And also maybe decimal points for, down to milliseconds and everything like that. And that gets calculated here, where basically the sampling rate, the sample length gets divided by the sampling rate, and we get a duration. This isn't being used yet, but it's just a good thing to have, so maybe later the duration could serve a purpose. But actually it is serving a purpose now. It just goes into swap 1, where it comes out basically the right outlet, and 1 comes out the left outlet. And basically when 1 gets divided by this duration, we're basically saying, how many samples per second do you need to play this back in order to play it at normal speed? And that's why we name this normal speed. And that's part of this mechanism over here where the normal speed comes in. And depending on where your playback speed is set, it will play it slower than that or faster than that using this math here to convert normal speed. And then that becomes the actual playback speed. So normal speed is like, if this was played at normal speed, this is the speed it is. The playback speed is what it actually is when you move the slider and manipulate it. Okay? And then down here, now we're going to get into the grains and stuff. We have normal speed. When that gets calculated, which is right here, after we have a sampling rate and a sample length and all this stuff gets calculated, and normal speed gets calculated, it gets received here. And it gets sent. Wait a minute here. Normal speed comes in, float comes here, and then there's a bang here. Okay, we're just using it as a trigger. Like when normal speed gets calculated, that happens after something gets recorded. It gets calculated. This just triggers our speed slider to zero out. It means like something you recorded just got loaded. You may have been doing other things before, but now that this just got loaded, let's zero out our speed. And so we're just using normal speed as a trigger here. And so what I'm going to do is take this and put this over here, because we're going to make more things like this next week when we start making our parameters more changeable, allowing us to do more effects and stuff. So I'm just organizing here and just also reviewing. Now, here we have our speed 0 send. Oh, this is the thing for whenever you hit that bang on the outside that says to reset the speed. its name is speed 0 send. And so it gets received here, and this tells the slider speed receive to go to 0. So I'm going to keep these together because these are all related to the same thing. Playback speed. That's what these are related to. This is kind of like calculations for figuring stuff out, what the normal speed is. And this is for controlling it. So I'm going to keep these things together. It'll just make, I think, a little more sense in the layout. And now I'm going to move this up here. We have our sampling rate, which comes in right from the beginning. But when the grain size gets sent right from the beginning, it basically calculates dividing the sampling rate by the grain size, which we have as a default is 100 to begin with. And it gives us a default grain speed. Basically, when you divide your sampling rate by the size of grains you have in your granule packet that you're sending out, you get the speed at which you need to send it out in order for it to sound like normal speed. So this is like basically a normal speed, but for the grain speed. Now, what I'm going to do here is see if I can get this all on. Can I get down here? All right. So from here, this is the thing that we were just basically talking about until I decided to do some housekeeping here. Although I think this housekeeping is going to be important. Oh, I just clicked on another window. I didn't want to go here. Go back. I just wanted to take you, expand you out there so you're all on screen. There we go. So here we are. This is the relationship between grain size and grain speed. Basically, you take your sampling rate, that's how fast samples are being played back. If you divide that by your grain size, which we're saying right from the beginning is 100, that's where we're going to start. We're going to change this into something that can be changed later, but not this week. But anyway, we're saying it's 100 to start, and then you divide your sampling rate by that, and then that's when you get your grain speed, meaning this is the speed at which you need to send these packets out in order for them to sound normal. What we're going to do next week is we're going to add things here to control grain speed and grain size, and that's why I kind of cleared up this area to have things associated with where they should be. All right, so now that we reviewed the relationship between grain speed and grain size, let's go back to our window here. What we're basically going to do is make a cosine waveform. We're going to use the oscillator object to do this. This oscillates basically a sinusoidal shape. And if we put a message up here, 0.5, that will put it 180 degrees out of phase. Phase in pure data is handled in a scale of 0 to 1. So this is basically 180 degrees out of phase. And we're going to see it in a moment, so this will make more sense then. Now, we want the size of the shape that we're going to put here, which is going to look like a cosine wave, just going up like this, like a bump. We want to make that the size, width-wise, of our grain size. Basically, we want that to be our grain size. So if we make an object here, $0 underscore grain size. Remember, this is made in, what do you call it? The loading subpatch. And I forgot to put the R in to say this is where you receive it. So we receive our grain size. That's the overall size we want it to be. And in order to make it this size, we need to tell it to do so. We're going to make a symbol box here. Symbol $0_Hanning. That's just the name of this table here. But remember, the $0 thing that we're using, so that this works as an abstraction, doesn't expand out of messages. So when we're about to put it in the message box, we got to do this to put it in there. And so what we're going to do here is make a pack object that's going to pack together this symbol, which is $0_Hanning, with the float. Now, symbol just means this is a combination of letters. It could be numbers, it could be underscores, all these things. It's just a symbolic name of something. And that's what it is. It's the name of this window. And then we're packing, and F means float, which is a number. We're basically packing in the number that is the grain size. Now, before we test this out, we'll actually have to send that. We'll have to record something. Oh, we'll actually have to go to that load bang menu, bang it, to make sure all our default values are sent, because this hasn't received grain size, because grain size is sent when the patch opens. So anyway, these things are going to be packed together in a message that is going to be the following. $1, that's the symbol there, which is this. We're going to say resize. We're saying $0_Hanning, you table, resize to this size, $2, which is this message that's coming out, the float. So they're being sent as one combined message here by pack, and so that way $1 means the first one in the list, the symbol, $2 means the second one in this list, which is the float, which is this number. Okay, so it's telling this thing to become the grain size. Alrighty, and then in this table, what we want to make is this cosine wave. We've already started it. Now, the thing is, for this waveform to work and be the right size for this window, it needs to be operating at the frequency of grain speed. So we're going to put in $0_grain speed, which we've seen before. It's the sampling rate. Oh, come on. We need to put the R to say receive. It's the sampling rate divided by the grain size. So all that happens. Now we need to do something in a way where all these things just, boom, happen pretty much at once in order to make this thing, and then can happen again when they're needed to do so. So I'm going to expand this down and actually do the following. Anytime the grain size changes, and this is just for the future because it's not right now, we don't have any way of changing it while we're using the patch. There's no slider or anything we made for that. We want to be able to change it though, and in order for it to change, basically we need to put in here a TBF. So the grain size comes in and it is a float, but this trigger converts that float into a bang, but also sends it out as a float. So we connect the float up there. That's where the grain size gets sent into pack again. But now we're adding a bang to it to say, pack, do your thing. Because if a float's just received here and pack in anything but the left inlet, it doesn't actually do it. It just stores it. So this means in the future when we change our grain size, boom, it will actually change the size of this table, which we will want it to be able to do. And then within this table, we want to make a perfectly sized cosine wave. So basically, I'm going to do it this way. Basically, this cosine wave that we're going to pop in there needs to all be sent at once. Okay. Now, we're going to do this in stages. And probably what's going to happen is we will change some of this patching as we make it more efficient. Let's have a float box. But to understand it, I think this is a better way of doing it. Basically, when grain speed gets received, goes into a float box, and it triggers this to happen. No, hold on here. No. No. We're going to do this better. Basically, in the future, we will want grain speed and grain size to both trigger these events to happen. So we need to set them up so that they do. So I'm going to make a trigger, bang, float, float. So actually, no, no, don't work that way. It doesn't work that way. Well, I'm getting it. We're gonna make this a trigger, bang bang float. So when grain size comes in, we already have a trigger bang float for it here. It will do this. Its float, its number will come through here, come out this float thing, go in here, bang this to happen, but we also want it to bang this stuff to happen. And that's where we're going to put a float box here, kind of like before. Just now I'm thinking straight. Looks like we don't need the extra banging, just a TBF. Okay, so I have to reconnect this, sorry. So triggers that to happen. I'll move things around later after they're hooked up to make them look nice. And we want this to happen. This guy is going to get stored in here. So the grain speed gets stored here so that when the size comes in, it all gets triggered to happen. This float gets in here to become the frequency of the oscillator. As you see, I hooked that up wrong. Right there. Okay. Now the thing is, I need something similar on this end. This triggers all these things to happen. I'm just looking for a nice place for it to be. That's all it is, just moving things around. So when this comes in, it triggers everything to happen. We need a similar thing for this side so that when the grain speed ever gets changed, it triggers all this stuff to happen as well. Hold on, what did I just do? Well, first of all, this red thing here, that was accidental. I went to make an object. I had something selected and it just made it. Okay, let me just check here. So, wait a second here. Yeah, the bang goes here. Yeah, that's fine. And the float from this guy goes there. Let's make this a TBFF. This middle one is one of the floats. So whenever the speed gets changed, the grain speed gets changed, it gets stored here. All right. Oh, hold on here. Trigger, bang, float, bang. Okay, so our middle one is still afloat. This is hooked up right. So when the grain speed comes in, its number gets stored here, where it can be banged whenever this number changes, but it also needs to be able to be banged whenever this comes in. And so this will be its trigger to bang that. So we have that bang also going into the left inlet of float, right there. And then over here, we need to use this bang to trigger all this stuff to happen. We can, we could do this. I don't want it to hit the trigger directly, because if it hits the trigger directly, then a bang comes in and it may not know what float to do because it's receiving a bang. I'm going to have this guy hooked up to a float box so it can go directly through whenever grain speed comes through. It triggers this stuff. Let's move this stuff down so that we see the curves of the patch cables, and all is well in the camp. Okay. And then whenever this speed comes through, we just want it to bang that float through so that the grain size being stored in here will come through and trigger everything to happen. Everything over here should happen as a result. Now, I'm just looking at this, and I want to make sure we don't get into any infinite loops. When grain size comes in, we do want it to go through this float and trigger this stuff to happen. It's triggering stuff over here as well as over here. You know what? We got to change this because this is doing extra duty. You'll see what I mean here. It's doing extra duty. Sorry, sometimes you just got to lay things out and figure them. First of all, over here, okay, hold on. Maybe not. Let me think here. I'm going to pause it, and then I'll bring you back with this figured out. Okay, got it all figured out. Basically, I wanted to make sure that whether grain speed or grain size are received, stuff gets calculated. So basically, let's say grain size comes in. Now, both of these things are calculated from the beginning. Remember, grain size gets banged out from the loading subpatch, and then in calculations, grain speed gets calculated, just dividing the sampling rate by grain size. So there's always, when the patch opens, values for these two items, because sample rate is always known to start. And so what happens is basically grain size comes in, or anytime it changes, it will trigger a bang, bang, float. The one bang just bangs the float box where grain speed is always stored. Whenever it changes, it gets updated in here, and it goes through and does its thing as well. But it basically gets stored here. And then this gets banged, which is the phase for the oscillator that we need to make it the right shape. And then this float goes through, which basically puts the number in here. It gets stored, but also goes through. And so basically the handing window gets resized anytime that happens. And the same thing over here. Whenever grain speed comes through or is updated, basically you're going to get a bang of its float into the oscillator here. You're going to get its float stored in this box as well. I don't know that that one is actually necessary. Yeah, well, it can't hurt. And then this bang bangs the phase for the oscillator, and this bang bangs the stored grain speed, so all this stuff happens. So basically, no matter which number gets updated, when we add those functions, it will happen. Now we just need to make the tab right to write this waveform to the table. So we're going to type tab right, tilde, $0 handing, and basically it will receive from the oscillator here. Now the one thing that I was worried about is, like, one of these numbers gets updated, it's going to go through these functions. Is there anything in here that's just going to loop and make it just keep happening over and over again? But fortunately, these two values do not send to one another. And in the calculation section, this gets calculating using grain size, but it's not, in other words, we're not making loops. Okay, I just don't want to confuse anyone there. All right, so now to try this out, we're going to close this. We're going to go to loading. We're going to hit this bang we have here, pretend like we just loaded the thing. And then we're going to right click or left click on window. And we didn't get, well, actually, I just realized there's a little bit more math I have to do there to make it an actual handing window. But we didn't get anything, which is not good. We should have gotten something. All right, receive $0 grain size. Let's say the 100 comes in here. It's getting stored. Oh, well, this is a problem right here. I can leave that float box there, but I gotta make a trigger, bang, float, because the symbol object gets banged to do its thing, and the float needs to be a number going into pack right here. So that's a problem that I had. Debugging. Debugging is a lot of what you do. So let's go through here and do this. I do need to change the oscillator's waveform also. But I should be getting something. No, we are getting a number stored there. We are getting this thing banged from both. Like, for example, the oscillator, I might as well put this in because it's got to be done. This oscillator would make a waveform that's basically going up and down, up to 1, down to -1, and we need to change that. So we can do that by multiplying it, and we have to use a tilde because it is coming out at the audio rate. Multiply, oh, it's changing the object. Never mind, hold on here. Oscillator, make a new object, star tilde 0.5. What that does is it cuts its size vertically in half. So now it's going up to negative, it's going up to positive 0.5 down to negative 0.5. And then what we need to do is push it up all to the positive by just adding to it, plus tilde 0.5. So now it should be all in positive regions. Okay, but we're not seeing it yet. Let me see if there's any errors that are telling me something I should be aware of. Yeah, I'm seeing some here. Let's see here. Bad for message. Float to object. I think, okay, bad message. I think it's our message right here that is probably it. This is what resizes the table. So let me just check something a second here. Okay, got it. Now let me just say what the problem was, and then I'll take you through the tour of the thing. Stay on the screen long enough so everyone can and you can also pause the video if you're copying what I'm doing. Now, the thing is, one thing I changed was semicolons before and after this message here, just like PD DSP1. I think this needed the semicolon on a line by itself, return, and then the message, and then a semicolon at the end of the line. Second thing, and this is probably the main thing, you need to bang tab right for it to write. So I had to add a bang being sent to tab right in both cases. So here, left to right. When a new number comes in for grain speed, it sends a bang to tab right. But remember, these things work right to left. And so the rightmost one bangs this thing through. That's the float over here that will then make the table the right size based on whatever the last grain speed was. Grain size, excuse me, whatever that was. And then a bang to bang the oscillator's phase through. Then a bang here to bang its own float through. Well, this isn't a bang, this is actually a float. So the float goes through the left inlet and just straight through. The reason why we still use the float box is that way it could be banged from this side to send whatever the last grain speed was through. And then the leftmost one is the bang to bang tab right to write it all to the table. Then on this side, basically, if the grain size comes through, the float goes through the left inlet of the float box and just goes straight through, resizes the table to whatever the new grain size is supposed to be, which we could think of as window size as well now that we've made a window. And then there's a bang here to bang the oscillator's phase, and then a bang here to bang whatever the last grain speed was through, so the oscillator's oscillating at the right rate to give us a cosine wave. And of course here, in all cases, it's cut in half and then 0.5 added to itself. So now you see it's on a range of 0 to 1. But we could visually also right click and go to properties here and tell this table to display vertically 0 to 1. This is data scaling here. I haven't really done this in Lorc yet. Let's put its bottom at 0. 0 to 1 is its range. Left to right is whatever its size is going to be, and you see it's being resized to 100, which is the default size of grain size. Okay, so now it's being displayed like this. So this is what we're really getting shaped on our amplitude. So I'm going to leave this here, pause video, take a snapshot, whatever you need to finally get this page correct. Okay, so now I'm going to move on. So we have this table, $0 Hanning, that we can now use over here in playback, our freshly cleaned and good looking playback area. And we're going to use it over here to fit over top of what's happening here. We're going to make a tab read. Or is this a tab oscillator? I think, yeah, this is a tab oscillator. No, it isn't. I'm sorry. Tab read 4 tilde $0 Hanning. So while it's reading chunks off of this waveform, this table is also going to be read. Now, what are the indexes for this? Well, it's not this output here, because this is the full length of the table, its samples values being added to the grain samples value, so it does eventually play through the table, albeit in chunks. What we need is output from here. This is the phaser multiplied by grain size. Those are the sections that we want to be read here, so that basically as these grains are being chunked out, it's taking this cosine wave and fitting it over top of it. And the way in which we integrate that is a star tilde somewhere right around here. So we're going to make a star tilde object here. And here, now, what you'll be hearing isn't perfect, but it's better. And then we're going to take one more step to make it even better than that. Save. So let's record and try this out. Hello, this should be a little bit smoother. Hello, this should be a little bit smoother. Hello, this should be a little bit smoother. Hello. Should be a little bit smoother. Hello. Okay, now one thing I want to do is this. Let's load bang everything from the start, pretending like we're starting over again. In fact, I'm going to save, close this, save, close this, and then open modules and hear how this sounds. I can't believe I closed that window. I have to go there again. AI, what is this? 302. That's the wrong place completely. Documents PD. The brain's getting farty again. No, we're on episode 3. Okay, modules. All right, so let's see how it. All right, so let's see how it. All right, so let's see how it. Okay, so basically what we're hearing is this sound with ridges all over it. But it is not as staticky grainy. All right, so let's see how it. But the way in which we make this better sounding, we're going to go here, and this will be our last step. Going into playback window here. And now this is why I was making, as much as I could, some space before. I'm going to have to make, let's do this like this. That doesn't look too bad. We got to make some more space. We got to put it in. All right. Move you all the way over. And it would help if I was able to move all this a little bit further to the right. And I can, because it's not all hooked up there. There we go. Just got this big old samp hold cable laying in the way. But that's all right. What we're going to do now, and this may seem a little bit extreme, but we're going to take what we've got. We're going to duplicate it, Control D. Or Command D on Mac. All right. Now what we basically have is two of these granulators running at once. Ultimately, that's not what we're doing. So what I'm going to take here is I'm going to take two of these, this bottom end off here, everything below this last star tilde here. Remember, this is where the handing window is getting applied, but we're going to apply it twice, but we're going to shift it off of axis a bit. Let's move this over here, and we're going to take, we have two granulators now, and we're going to add them together. Plus tilde. You go into there. You go into there. Then you go into here. Well, that looks fine like that. Now up here we got to do a little bit of changes. Basically, we're going to take all these bits off here right up above phaser. And we're going to use them from over here. What's being sent to this phaser is going to be an in-phase version of this granulation within the handing window. And this is going to be an out-of-phase version of it. We're basically going to say times and actually, you know what? This is actually below phaser, I believe. Yeah. Now, does this still have the samp hold connected? No, it doesn't. We still want this going into this guy's samp hold. All right. It's just we want its phaser out of phase with the other one. And the way we can do that is, first of all, just let me pause one moment. I want to make sure I get this right. Okay, I was just looking at I was looking at screenshots of when I had done this before. All right, we need a star tilde, 0.5. This is what it's going to get us halfway. And yet, we're not using this phaser. So we're taking it out. But we're going to use this, which is basically just going to take whatever the output of this phaser is. It's going to multiply it by 0.5, which means its range will be 0 to 0.5. But it starts on 0.5 and basically will wrap around, because we're going to add to it an object called wrap, W-R-A-P tilde. What this takes is values between 0 and 1 and wraps them around, meaning like as we go to 0.5 up to 1, it'll wrap it around to 0 to 0.5 again, kind of like putting it on the other side of the circle. Think of it as like a circle that starts at 0, ends at 1, which is right next to the beginning of the circle again. And what's happening is this is wrapping it around, basically giving us an out of phase version here. Now, this samp and hold over here is receiving the output from this table, and yes, it is receiving the wrapped version of phaser. Not this phaser, but the wrapped version of it. We should be good to go. Let's hear it now. Hold on a second. What's going on? Okay, I probably didn't hook something up right that we're not hearing anything. Okay, let me see here. These two things are being added together. Oh, and they're going to the right inlet instead of the left inlet here. There we go. That does it. Hold on a second. What's going on? 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 Hold on a second. Okay, so what we basically got now is, and this is definitely, you know, what the intention was, to make this a granulator. It's no longer a smooth playback of the synth, but we got rid, or playback of the waveform, but we got rid of the distortion that was happening there by using this handing window. Now, what I did at the end in taking like this second version of the granulator, hacking its phaser off, was basically, we have one of the granulators basically having this sitting on top of it, keeping it from distorting. This is cycling along with it in timing with the grains, that the grains are populating this area in here and are zeroing out at the beginning and the end. That's why it sounds pretty ridgy. All right. But in order to make it a little bit smoother than that, we made an out of phase version. Imagine this, that's sitting here like a big old bump. Its out of phase version is coming from up here, going down here, and then going back up. So imagine those two shapes interlacing with one another. That's what we have now. So now we have a much smoother playback and sound. One thing I want to do with this table is right click on it, and we're going to Bezier curve it. That will look better than what we're getting right now. There we go. So, I'm in edit mode. So you can get some really cool sounds with this. What we're going to do next time is make slider controls for the grain size and the grain speed, so we could control those factors as well more easily. And that's what we'll be doing next time, so it'll actually be a shorter episode, and I think some of my students would appreciate that. But just to give you a taste of what that would be like when manipulating those values, let me just make a sound that is definitely different than me talking. Oh, hold on. Jeez. Yeah, I want it to be as solid as possible. Yeah, that's the kind of stuff I like. But you see, it'd be nicer for us to be able to lay out those kind of controls. And I didn't even mess with window size. What happens if I do that real quick here? Window size. I'm just going to send a quick message of, let's say 500. All right, well, so you can see some of the stuff you can do. But right now we have window size, or Actually, I'm calling it grain size and grain speed kind of connected together in this calculations subpatch here. So what I want to do is basically, next time we're going to finish this off by making these more full featured. We'll be renaming some things so that way we'll have our baseline thing where we can always get back to our standard grain size, our standard grain speed, just like we can get back to the 0 value of our standard speed of playback here with this button. Basically, I want to be able to get back to that with all 3 factors, so you kind of can gauge your bearings, but you are able to change the windows or the grain size without changing the grain speed. I want to make those independent of one another so that you have all 3 of these factors that you can play with. So anyway, that is what we're doing next times. And, well, thank you for joining me. And farewell. Thanks for all the fish.